Have you ever read a book that changed your life? In 2013, I spent my summer holidays in Eastern Germany, in a little village, reading a book about big data. At that time, I had just finished my PhD in economics. My life was at a professional crossroads. I didn't want to stay in academia, but I still wanted to use my skills in statistics and data analysis. And I wanted to do something meaningful with it. Now, what is meaningful? In that book that I read about big data, there was one particular project, one example that really struck me, and that had a tremendous impact on what I've been doing ever since that moment 2 years ago. That project analyzes data and potentially saves lives. And it's done by the New York City administration. Now, doctors analyze data and save lives every day. But here's a city agency that can have this fantastic impact. And that's the potential of data-driven innovation. Now, how did they do that in New York? It's about buildings in danger of fire. And it's about sending out inspectors to endangered buildings, to dangerous buildings. Now, the data tells you where to send your inspectors to the most dangerous buildings. So this is where the analysis takes part. I don't want to bore you with the statistical details. It's not even rocket science, but it's definitely an innovative idea. So I started to collect every snippet about the project I could possibly find out there. I became a big fan. I even applied for an internship with the New York City administration. These guys suddenly were my heroes, and they never answered to my application. Okay, at some point I understood the DNA of the project, I understood how it was done, and I couldn't work on it in New York City. So I had the idea to bring it to Germany, where I live, to basically copy the project, or better, to fit it to the local context so that it's rather a replication than a straight copy. Now, all I needed was a problem in Germany that involved inspections. Okay, maybe this can help. Lasagna and horse meat. Yeah, of course, the fabulous horse meat scandal. When back in 2013, authorities all over Europe found horse meat in food products where the label said, for example, 100% beef. Now, that's not what you want. And that was obviously an issue of the food inspection system where it had failed. So what I did was I tried to find out who was responsible for organizing food inspections in Germany. I contacted one federal state agency that does exactly this. I was invited, I presented the New York City project, and I suggested to replicate the project, to use the data of this agency in Germany to analyze the data so that they can better target their food inspections and send the inspectors to the right places. Now, what's happening if you're young, if you don't have an established company with an impressive track record, and you're trying to sell cutting-edge technology, machine learning, artificial intelligence, stuff that is currently tried out in New York City to a German federal state agency? Yeah, you know the answer. It's just not happening. Maybe I was a bit naive at that time, but I don't regret it, because the core idea is still valid. And that is, try to copy successful projects, try to replicate them. And that applies not only to cities, but also to nonprofit organizations. And think about it. It even becomes more powerful if that idea is combined with open source code and open data. If I know the code, I see exactly how the project is done, which helps me tremendously. And it becomes even easier if the data is open. That means freely available and machine readable. Now, the project with the federal state agency in Germany didn't happen either. But I started my own private collection of such projects which use data to do social good. And out of this private collection grew a startup called DataLook. DataLook facilitates the replication of data-driven projects for social good. And this summer, my team and I, we started a campaign where we motivated people from all over the world to replicate projects in their cities. And I'd like to share one story that happened during the campaign. It's about a project called Cycle Philly. Cycle Philly is a smartphone app that allows you to record your bicycle trip data if you're living in Philadelphia in the United States. And you can donate your bicycle trip data to the city officials who are responsible for planning bike lanes. And this kind of data is tremendously helpful for their work. So this app is open source. And the replication story began with a message we saw on Twitter. A German lady called Uta wrote on Twitter that she saw the project on our website, she really likes the project, and she's willing to donate her own bike trip data if such an app would exist in Germany. So we responded to this message by posting something on a Google Plus group where German programmers hang out that like to work on such projects. And we asked them, does anyone want to do a replication of Cycle Philly in Germany? And Christian replied. And he said, yeah, it's a cool idea. It's a great idea. I want to start working on that. I want to bring this project to Germany. I want to bring it to the city of Düsseldorf. So Christian started working on it. And a few days later, he sent me another message saying, OK, Tobias, but do you know if I can use the Cycle Philly logo for my replication? I had no idea about the copyright issues. So what I did was, again, use Twitter and send a message to the team in Philadelphia, who was behind the original project. 6 minutes later, they answered. They were so excited that their project is being replicated in Germany that they offered to create a new logo for Christian's replication for free. And here it is, Cycledorf. And it even has the skyline of Düsseldorf in it. Now, isn't that a wonderful cross-Atlantic collaboration sparked by the belief in doing good with data? Christian also talked to the mayor of Düsseldorf and to the city official who is responsible for planning bike lanes in Düsseldorf. Both were excited about the replication. They fully support it. And the bike lane officer even told Christian that a couple of years ago, he was approached by a company who wanted to produce a very similar smartphone app for the city. However, coding it from scratch would have cost tens of thousands of euros. And because of that obstacle, the project never happened. Now Christian enters the stage. He does a replication, which is basically a one-to-one copy. Very easy, it doesn't take much time. He does it even for free for the city. And this is where the impact is. Replicating projects is a very simple idea, yet powerful for cities and nonprofit organizations if combined with open source code and open data. So I urge you to look for successful projects, to replicate them, and to use data for social good. Now I invite you to imagine what impact we could achieve with this idea if applied to the really big problems in the world. And here's Pascal Weinberger, 18 years old, who dreams about using code, algorithms, and data to tackle the effects of natural catastrophes.
So an 18-year-old guy on a TEDx stage. How and why? Well, let me tell you how. I'm curious, and I think everybody of you is. And all I did to get here is follow my curiosity, making use of various open resources for learning, like open code, open data, and free university courses on the internet that taught me pretty much everything my curiosity led me to. But the big question remained, which is, what should I do with all these skills? I wanted to do something meaningful. I always wanted to make the world a better place. 200,000 people are affected by them every year. 11 billion US dollars of estimated minimum damage were induced by them just in 2014 alone. I'm talking about natural catastrophes here. Natural catastrophes mostly happen in remote areas where there's almost no infrastructure and warning systems in place to help people be informed about them. And this is a huge problem. We live in a connected world. We have to care about people living remotely, not in our areas. So that's exactly what I wanted to do over the summer. I wanted to use open data, open code, and the skills I've taught myself to create a platform for everybody. a service that uses all kinds of open data streams like seismic streams, Earth magnetic field data, satellite data, and in situ data to analyze them for anomalies and create predictions or at least evaluations for risks out of them. Now it's valid to say that there's many smart scientists working on them, and why would you need an 18-year-old guy adding to that? So the problem of that is that scientists mostly focus on areas where there's research being funded. And that's mostly areas where there's less earthquakes and disasters happening. Also, if you look at the scientific output produced, it's really hard to find because it's distributed over many different specialized platforms and sources with many different formats that are often really hard to find and understand if you're not a scientist already. So using this data and gathering various different data sources that were available for scientists, with the help of Jim Lee, the NUPE community, and some others, we already built a platform and gathered some really cool data sets for everybody to use and look at. You can learn about earthquakes. Seeing all the earthquakes that happened over the last month on a cool 3D visualization with all the tectonic plate boundaries, and now you can start thinking about why earthquakes happen and how they are produced. You can start educating children about that with a cool tool that they might use and just play with it. At the sidebar, you can also find links to easily understandable resources that will kindly hint you on the things that you can do in order to prepare and help people that are affected by natural catastrophes. You can also stay informed about the drought that is currently happening at the west coast of America. Here you see in red the heat wave that affects America, as well as the accumulated rainfall over the last 30 days. And this is a pretty basic analysis you can do, and obviously you see where there's drought, there's no rain happening, which is why it's dry. But maybe you're more interested, or in that case not interested, in nuclear power plants in your neighborhood. You can learn about them here as well. But these are only 3 small examples of things you can already do with that platform. Honestly, I urge you to take a look at that and play around with it yourself. But frankly, it's still far from being done. One of the initial ideas, and probably the most powerful one, was to use seismic and other in situ streaming data to analyze them for anomalies and build evaluation models out of them. Now, why did nothing happen there? The answer to that is as simple as it is worrying. These kind of very valuable streaming data sets are just not made easily available to the public. Scientists are probably easily able to use them, as we've just learned, but people like me, datanauts, or just curious people cannot use them and find them on the web. Now, football games and other sports events are live streamed for everybody to watch all over the world. Why isn't the same true for Earth observation data? Now, once data like this would be made available, we could use that to run anomaly detection algorithms on them and build an evaluation platform for risks and find anomalies in seismic, for example, data streams to better help and add to currently existing prediction models to find where earthquakes are most likely to happen. This can also be made available online and accessible for everybody, also on mobile phones. For example, here you can see the internet usage and ocean cables all around the world on a mobile phone. Now, this is a pretty powerful technology, and all we could use to do that is publicly accessible streaming data, and then you could easily find out if it's really worth doing projects like putting sensors within internet cables for streaming and finding earthquake predictions within internet streaming data. So I myself was standing here about 3 months ago, pitching an idea to build exactly that, global anomaly detection model and a cool 3D visualization. And all we would need for this to be done and for this future to become reality is open the data that is currently already produced and just make it available to the public for everybody to easily find it, to easily understand it, and to easily use it. And that would enable us to live in a world full of Datanauts, full of people that have very easy access and easy ways to work on the world's greatest problems and find solutions to them without any barriers and any obstacles of data formatting and data resource finding and things like that. And I think this can be really a future worth striving for, and I would kindly ask everybody of you to help us do that. Thank you.